Take a look at this map. For centuries, moving a cargo ship between the Atlantic and Pacific Oceans required sailing all the way down the coast of South America and navigating the brutal waters of Cape Horn. This mandatory detour added weeks or even months to a voyage. It drained fuel reserves, spiked shipping costs, and forced crews into violent storms where shipwrecks were a constant threat. The geography presented an obvious solution. Right in Central America, the two oceans are separated by the Isthmus of Panama, a narrow strip of land barely 50 miles wide. To accelerate international trade, humanity had to figure out how to slice directly through that terrain. In the late 19th century, a French engineering team arrived to dig the first canal. They had recently completed the Suez Canal in Egypt and planned to copy that exact model here. But Suez was a flat, dry desert. Panama is a jagged mountain ridge covered in dense jungle. When the tropical rains arrived, local rivers would swell in hours, and the steep, freshly dug hillsides would liquefy into sudden, devastating mudslides. Worse than the mud was the biology. Outbreaks of yellow fever and malaria tore through the camps, killing thousands of laborers and bleeding the project of its manpower. After years of trying to carve a straight, sea-level ditch through an active tropical mountain range, the French ran out of money and abandoned the site. The environment proved impossible to conquer with brute force. When the United States took over the project in the early 20th century, engineers realized that heavy machinery was useless if the operators kept dying. They had to control the environment before they could move the dirt. They launched a massive, systemic, sanitary engineering campaign. Crews drained swamps, fumigated the buildings, installed mosquito mang, and systematically eliminated breeding grounds across the canal zone. This drastically reduced the spread of malaria and yellow fever, allowing the workforce to actually survive their shifts in the jungle. Controlling the local biology was the absolute prerequisite for construction. With the outbreaks managed, the real engineering could finally begin. The Americans abandoned the failed French idea of a flat, sea-level trench. Instead, they designed a massive water elevator to carry ships over the landmass. To tame the unpredictable flooding of the local Chagres River, engineers built a massive dam. They captured those wild floodwaters to form an enormous artificial reservoir called Lake Gatun, located 85 feet above sea level. To connect the oceans to this lake, workers blasted a 9-mile canyon through the divide. In the Culebra Cut, armies of men and steam shovels carved away millions of cubic yards of unstable rock, fighting constant landslides to keep the channel open. This cross-section shows the concrete lock chambers used to lift vessels. When a ship enters, doors close behind it and a valve opens. Gravity pulls water from the lake into the chamber, raising the ship without electric pumps. The vessel is lifted step by step, sails across the lake, navigates the canyon, and descends through the opposite locks. The clearances inside these chambers are incredibly tight. To keep the ship centered, specialized electric locomotives, known as mulas, roll along the lock walls. They hold the vessels exactly in place with heavy cables to prevent them from crashing into the concrete. The entire waterway acts as one integrated industrial machine, entirely dependent on local rain, precise mechanics, and gravity. When traffic began flowing in 1914, a journey between the east and west coasts of the Americas was instantly shortened by thousands of miles. This diagram shows a standard known as Panamax. For decades, global shipbuilders designed cargo vessels specifically to fit the exact dimensions of these lock chambers, leaving only inches of clearance on either side. Because these specific ships became the baseline for moving goods, ports, cargo cranes, and shipping channels across the globe had to be physically sized to handle these precise vessels. As global consumer demand surged, vessels grew well beyond those original limits. To keep up, Panama completed a massive expansion in 2016, adding a new, wider lane of locks capable of handling the colossal Neo-Panamax container ships we see navigating the canal today. The physical dimensions of a 50-mile stretch of Central American jungle directly dictated the architecture of international supply chains for a century. Today, the entire lifting mechanism relies on fresh water from Lake Gatun, which requires consistent, heavy rainfall to stay full. Every time a ship passes through, millions of gallons of that fresh water are flushed out into the ocean. During dry seasons and droughts, the lake levels drop, forcing authorities to restrict how many ships can cross. Whoever controls the flow of this local water supply directly dictates the transit times, shipping costs, and inventory flows for multiple continents. Human engineering carved a path across a mountain range and replaced it with a gravity-powered machine, and the pace of modern commerce still depends on the rain falling over that narrow strip of land.